Hello, my name is Taylor Ross. I'm an Aximmetry ambassador and the owner of Frustum Virtual in Los Angeles, California. In this tutorial, I'll show you how to bring your custom Unreal Engine project into Aximmetry DE Composer. First, we need to open Aximmetry DE Composer. I have the broadcast license. The first thing you'll see is the Aximmetry Composer startup configuration. This is the video output devices page. I have two desktop monitors connected directly to my graphics card and one SDI output connected to a monitor that's mounted on my camera. First, we will cover the indexing of all of our video output devices. My primary monitor will have no index, my secondary monitor will have index 1, and my SDI output will have index 2. If I set my primary monitor to index 1, you will see a number 1 in the upper left-hand corner. I will leave my primary monitor index blank so that I have a place to interact with the Aximmetry DE Composer once it launches. So my secondary monitor is index 1, and my SDI output is index 2. Select the three dots next to the SDI output to change the resolution or frame rate. My SDI monitor has a built-in recorder. I will be using this monitor to record my final pixel output. Make sure to set the frame rate to the frame rate that your camera is currently recording at. Once you've selected your frame rate and resolution, you can just select OK. Now on the left-hand side of the startup configuration, we'll select Device Mapper. In this category section, we will find camera tracking and select it, and then we will select Manage Devices. If we scroll down to the Game section, Game has OpenVR and Anti-Latency. OpenVR is the HTC Vive. Anti-Latency is the anti-latency system. If you have any other camera tracking solution, it will be in the camera tracking section. In this Use Device setting, we can use this drop-down to select the device that's currently connected to this computer. With my device selected, I'm just going to select Apply and then OK. Now back in the Categories section, we will select Zoom Encoder and then select Manage Devices. If we scroll all the way down, you'll see Zoom Encoders. I'm using the LowNet 2 IndyMark. I already have the LowNet 2 server set up, but if it wasn't, or if this is the first time setting it up, this would be blank. If this is blank, we will just select our Add button. Now the UDP port and the Join Multicast group should be auto-populated for the LowNet 2 server. I can open the LowNet 2 server to double check these settings. In the LowNet 2 server, you can see that the multicast group and the UDP port should match. My multicast group is 236.12.12.12, and my UDP port is 60608. You can also see that the name of the camera is correct, camera 1. You just want to make sure that the camera is named properly so that when you open it in Aximmetry DE Composer, it will keep everything more organized. Select OK. Once the LowNet 2 server has been added with the correct settings, I will just select Apply and then OK. You can also create presets for any of the devices in this category section. With my camera tracking selected, I can use this drop-down to select the device that's connected to my computer. This preset will be loaded when you launch Aximmetry DE Composer. This would be for my camera tracking. This would be for my zoom encoder. For this tutorial, I'm going to leave all of my presets blank so you can see how to load them once you're in Aximmetry DE Composer. Finally, I'll navigate back to Video Outputs. I'll make sure that everything's correct, and then I'll hit Apply and Start. Once Aximmetry loads, all you'll see is a blank sequence editor. The first thing I like to do is come up to Edit, Preferences. In this Rendering Settings, I'll make sure that my frame size and frame rate are correct. My frame rate is 24 frames per second, which is what my camera is recording at, and my frame size is set to 1920 by 1080. If you're recording at a different frame rate, you can select it here. If you'd like to change your frame size, you can select it here. Just note that if you set this too high, it will impact the GPU performance. So if you're having a lot of issues with performance, just make sure that your frame size isn't set too high. Once you're happy with your selection, just hit Apply and then OK. Now we need to add a new compound, so we'll come up here to the New tab. Select Compound or Control-N on your keyboard. Now that we have a new compound, we need to add the type of camera that we added to our custom Unreal project. On the left-hand side under Projects, select Common Studio and then select Camera. In this folder, there's a list of cameras that can be added to your custom Unreal project. In the last tutorial, when we were setting up our Unreal project, we added the mixed camera. There are two types of mixed cameras in this folder, MixCam 3x3 and MixCam 8x8. The difference here is that it will add 3 or 8 cameras. For this tutorial, I'm going to add the MixCam Unreal 3x3, we can just click and drag this directly into our compound. This will add Mixed Cam Unreal 3x3 to our compound. You'll also see that it added tabs Camera, Billboard, and Tracked Inputs at the top. Now we need to add the custom Unreal project to our compound. By default, this is in Documents, Unreal Projects. Mine is called Living Room Set 04 with a 5.3 at the end. I will open this Unreal Project folder. In this folder, we will find the Unreal Project. I will click and drag this directly from the file browser into the compound. You will see that this is loading in the processor load in the bottom right. Once the Unreal project loads, you will see that there are pins that have been created that match the names of the pins that are on our camera that we added. I'm just going to click and drag from each pin to connect it to the pin with the corresponding name. Once all of these pins are connected, I'm going to click and drag from out to rendered and from bmask to bmask. Now we are going to click and drag from preview to the output bar on the right. Next, we will click and drag from out to the preview bar on the right. When these are connected, they will give you the option to rename the pin. I'm just going to select OK. At the bottom, we will see a Preview 1 and Preview 2. Preview 1 is my secondary monitor, and Preview 2 is my SDI output. Next, we will navigate to the top and select the Cameras tab. In this tab, we have Select Camera. We have Virtual Cam 1, 2, and 3, as well as Tracked Cam 4, 5, and 6. The reason we have both styles of camera is because we added a mixed camera to our compound and to our Unreal project. This gives us a virtual camera and a tracked camera. Depending on what camera you added to your custom Unreal project, you may only see virtual camera inputs or tracked camera inputs. At the top, the Billboard tab corresponds to all of our virtual cameras, and the Tracked Inputs tab corresponds to all of our tracked cameras. Next, we'll navigate to the Billboard tab at the top. Here you'll see all of the inputs, input 1, 2, and 3, which correspond to the cameras Virtual Cam 1, 2, and 3. Back in the Billboard tab, you have a monitor section which has input, cropped, keyed, and final. Crop settings for this input correspond to this orange square. Keyed settings correspond to this green square. First, we will select input. You should see the live input in Preview 1 and Preview 2. With input selected, you should see all of the input settings on the right. The first setting is input device. You can use this dropdown to select your input. I know my live camera feed is coming into the Blackmagic DeckLink 8K Pro 1. Once this is selected, I will see the live feed in Preview 1 and 2. Next, we can adjust this mode setting. I already have video coming in with auto selected for the resolution, but I also know my camera is sending a 1080 signal at 24 frames per second, so I can specify that here and then select OK. There are some additional settings here on the right: timecode master, in color space, in gamma curve, chroma offset, vignette correction. Feel free to play with these settings on your own. For this tutorial, I'm not going to change any of these settings. In the monitor 1 square, the next thing we'll do is go to cropped. This corresponds to this orange square called cropped 1. The crop settings on the right will allow us to crop our image. I can see off my green screen a bit on the right hand side. I will use the slider labeled right. Click and drag on this slider until all we can see is the green screen. This will also reposition my image to the middle of the frame. The goal with this crop setting is to make sure that I am only seeing green screen. If you're shooting vertical, you can also use this portrait setting. Turning this setting on will turn your input 90 degrees. Now in the monitor 1 setting, we will go to keyed. This corresponds to the green square labeled keyer 1. So on the right hand side, you see all the settings for the keyer. We're using the advanced B keyer from Aximmetry. For the monitor mode, we're set to final. I'll change this to input. And then for the background color, we have this green square. If you click the green square, it will allow you to choose your background color. There's an eyedropper down here in the bottom left-hand corner. If you click that and drag, make sure you're continuously holding your mouse down. You can select the green color of your green screen, so I'll let go of that here, and it will select that color. Once you have your color selected, you can select OK. The next settings that you will see are low cut and high cut. These settings will allow you to fine-tune the compositing of your green screen. I will go back to monitor mode and select matte. This will change your Preview 1 and 2 to a black and white image. The goal here is to make the black completely black and the white completely white. The areas that are black represent our green screen, and the areas that are white represent our talent. We will start by adjusting the low cut. These are the black sections of our image. Click and drag the low cut slider until the black areas are completely black. Once you are happy with the low cut value, you can adjust the high cut value until the white is completely white. You can see that there's still a little bit of bleed in the black sections of our image, so I will readjust the low cut setting. Now in monitor mode, I will go to final. This will show us the final composited image coming directly from our live feed of our camera. Now in the monitor 1 square, we will also select final. The reason we're not seeing anything here is because our virtual camera is not placed at world 0. So I'll go back to the cameras tab. We are currently on the first track of our camera 1 path. Below our camera paths, we have camera and render setup, as well as edit camera path. If I select the A of our edit camera path and then hit this X, it will reposition my camera to the 0, 0 point of our Unreal scene. I'm going to do this for the B position as well, just to zero everything out and bring us back to the center. Now we can go back to our A position of our camera path. With our mouse over our preview monitor, we can click and drag the left mouse button to pan and tilt. With our middle mouse button, we can click and drag to move up and down or left and right. You can click and drag the right mouse button to dolly in and out or left and right. Now I'm going to use these 3 mouse buttons to reposition the camera in my scene. When I was setting this scene up on the Unreal Engine side, I had placed my camera in a specific position. So I just want to find that position. Once we're happy with the placement of our camera in the Unreal scene, we will reposition the billboard. You can see the billboard or the live camera input represented by this chair on the right-hand side of my frame. To reposition the billboard, we will go to the Billboard tab at the top. Now on the far right-hand side of Input 1, you will see Billboard 1. With the Billboard 1 square selected, you will see all of the billboard settings on the right. To reposition the billboard, you will use the transformation settings at the top of the settings list. In the POS or position setting, you can click and drag any of these values up or down. You should see the billboard moving when you adjust these settings. Since I'm still in edit mode in my camera tab, I can continue to reposition my camera. I will just slightly adjust my camera to get a better view of my billboard. My billboard seems a little bit large for my Unreal scene, so in the transform settings, I can adjust this scale value. I'll bring it back down to 0.7. This is a little bit too small, so I'll go up to 0.9. I'll split the difference and go with 0.8. That scale seems a little bit better for the size of the chair in this room. There are a few settings that I will go into more detail about in another tutorial. The next setting that I'm going to cover is this look at camera function. If we turn this off, the billboard seems to have disappeared. The billboard is still here, it's just not looking at the camera. We need to adjust the rotation setting in order to see the billboard again. An important concept to understand about our billboard is that it is a 2D plane displaying our image in a 3D world. In order to see this video feed, the billboard needs to be looking directly at the virtual camera. With a rotation value of 90 degrees on the Z-axis, the billboard is now looking directly at the virtual camera. The flip function allows you to flip the image without going into a negative value in the rotation. The lit setting is a very powerful function. This will use the Unreal lighting to light your billboard. With this setting turned on, you can see that the billboard now blends into our Unreal scene much better. Just below the lit function, we have a cast shadow function. This will use your billboard to cast a shadow from your Unreal lighting. You can also adjust the shadow depth, shadow offset, and shadow rotation. Render to depth and inverse tone map will allow you to further adjust the look of your billboard in the Unreal scene. The show AO function or ambient occlusion will add another type of shadow under your billboard. With this function turned on, I will adjust the height of my billboard to see this shadow. The middle value of our position transform is the Z-axis. Once you adjust the height of your billboard to see this shadow, you can use the lift function to bring it back down and match it to the bottom of our talent. Before moving on, I'm just going to make a few more slight adjustments to the position and scale of my billboard. Scale seems a little bit big still, so I'll downsize that one more value. Let's do 0.7. Now if I come back to my cameras tab, we're still in the A position of the edit camera path. There's a copy function just to the right of our A and B position. I will copy this position, select B, and then paste it using this clipboard. Now the A and B position will match in our edit camera path. With the B position selected, I will reposition my camera once again to get a better view of my billboard. Once I find a good position, I will navigate back to the edit camera path and select play. You can now see that the camera is moving between A and B in an infinite loop. You can adjust the direction and feather of this movement using the other functions in edit camera path. In this camera 1 path section, you can see that you can create up to 16 different camera movements. If I select camera path 2, select A, and then paste the original camera path that I copied from camera path 1, select the B position and paste here as well. With the B position selected, I will adjust my camera position. Now I will select play again. You can create up to 16 custom camera paths using this A and B position. You can also use a sequencer, which I'll cover in another tutorial. Now I can switch in real time between these two camera paths. You will see it update in Preview 1 and Preview 2. This is very useful because we don't need any camera tracking to do this. Now that you understand the A and B camera paths, I will select Camera 1 path. On the right hand side, you'll see a master speed slider as well as all of the path durations. The speed of camera path 1 is currently set to 5. If I increase this value to 15, it will now take 15 seconds for this camera path to complete in one direction between A and B. In the camera and render setup, I can also go to mouse, which will give me more of a 3D view of my scene that's not from the view of my camera. So from here, you can also see that the billboard is flat. If I go back to this camera, this is my final render view from the virtual camera. Now I will navigate back to the billboard tab. Now that we have covered all of the basic settings for virtual camera on input 1, the last thing I want to cover for the virtual camera portion of this tutorial is this test button under input 1. Navigate back to the flow tab at the top. On the left hand side of our mixed camera, you'll see test input 1, 2, and 3. Select the folder labeled common under projects. Then select videos. Select green. This folder is full of green screen footage provided by Aximmetry. The technique that I'm about to show you will work with any pre-recorded green screen footage that you have. I will select this footage and drag it directly into our compound. I will then click and drag from the out pin into test input 1. Navigate back to the billboard tab at the top. In input 1, I will turn on test. In the preview monitor, you will now see that this test input footage is playing instead of my live camera feed. Select the crop setting under monitor 1. This footage is recorded in portrait mode or 9:16. So I will turn on this portrait function in the settings on the right. We should see that the footage has turned 90 degrees into the proper orientation. We will need to adjust the keyer settings for the green of this green screen footage. Change the monitor mode to input. Select the background color with the eyedropper. Select OK. Change the monitor mode to matte. Now we need to adjust the low cut and high cut values. I'm just quickly adjusting the low cut and high cut values. We are just trying to use the minimum amount of high and low cut to remove the green. Under monitor 1, we can go to final. Now my billboard has been replaced with this test footage. We'll need to readjust the settings for input 1. Starting with the scale, we'll go back to 1. I'm also going to quickly adjust the position of my billboard now. I'm just going to line it up in the position where the feet start to clip through the floor. For the look at function, I'm going to change this to at camera. I'm also going to remove the rotation that we added. Navigate to the cameras tab at the top. Adjust the A and B position so that we're not clipping the head of our billboard. This is just a quick example of how you can use pre-recorded footage for your billboard. If I go back to billboards and select billboard 1, I can play with some of these settings some more. I can turn off lit to see the original lighting of this footage. This test function is a very powerful function for any pre-recorded green screen footage. So now that I've showed you how to properly set up all of the settings for the virtual camera, I'm going to go into the tracked camera inputs. First, we're going to navigate back to the flow tab. I'm going to remove this test green screen footage by deleting it. So just delete this. This is just to save on the processor load for my GPU in frames per second while I record this tutorial. Next, we'll navigate back to the cameras tab. TCAM 4, 5, and 6, or tracked camera, all correspond to this tracked inputs tab, 4, 5, and 6. Make sure that you have input 4 selected. This will show you all of the settings for input 4 on the right-hand side. The first thing we need to change in the settings is the camera device. We'll use this drop-down to see all of the available input devices. I know that my live camera feed is coming in on Blackmagic Decklink 8K Pro 1, so I'll select that. You can see that Preview 1 and 2 have been updated with my live camera feed. Next, we can adjust the camera mode. Use these 3 dots to change the resolution and frame rate. With auto selected, I already have a live camera feed coming in, but I know my camera is sending a 1080 at 24, so I'll set that and then just select OK. For the tracking device, I'm going to use this drop down and select my game anti-latency device 0, which is the camera tracking volume that I'm using. You can see preview 1 and 2 have updated once you select your tracking device. For the calibration profile, just going to use these 3 dots and select the calibration profile that we created in the camera calibrator and basic calibrator for Aximmetry. I'll select my 35mm calibration profile and then press OK. For the zoom device setting, I'll use these 3 dots and then select my zoom encoder. This will be controlling the focus in the virtual scene. You can see that my virtual scene's focus is updated in preview 1 and 2. There's a few other input settings that I'm not going to adjust in this tutorial, but you can mess with them on your own. Track forward port, use audio device, audio devices, timecode master, in color space, in gamma curve, chroma offset, no input image. I will leave all of these settings alone for this tutorial. The manual lens settings would be if you didn't set up a calibration profile. I will quickly turn this on to show you what it does. You can see that the manual zoom is set to 1. You can click and drag to increase this manual zoom value. This will allow you to manually match the zoom of your focal length. So if you didn't create a calibration profile, this is how you would set your focal length to match the focal length of your physical camera. It is possible to get your manual zoom to match the focal length, but I would recommend going through the calibration process because it is much more robust and you will get a better final result. With the manual zoom setting selected, I will hit Ctrl Q on my keyboard to reset it to 1. Just below manual zoom, there is a manual focus setting. This will adjust the focus of my virtual world. You can click and drag to slowly increase this value to set the focus of your virtual world. You can see this manual focus in preview 1 and 2. With the manual focus setting selected, I'll hit Ctrl Q on my keyboard to reset it to the default value of 0. Because I'm using a calibration profile, I will turn off the manual lens setting. I'm going to leave external lens data turned on. Next, we'll see camera delay. The camera delay setting is used to delay the incoming live camera feed. This would be used if the camera feed is coming in faster than the tracking data. Normally this isn't the case. The tracking data will be coming in faster than the live camera feed. Just below camera delay, we have timecode sync and zoom timecode sync. I will leave these turned on. Just below these sync settings, you have detect tracking delay and detect zoom delay. These 2 settings will auto-detect the delay for your devices. I will come back to these auto-detect settings once we have our studio calibrated. You can change the detect target color of these auto-detect settings using this drop-down. You have the option for red, green, or blue. I will set mine to red because we're recording on a green screen. You can also manually input these delays. This is a bit more time consuming and it takes 2 people. You need 1 person to pan the camera back and forth while you adjust these manually. The tracking de-jitter setting is used to remove the jitter of your tracking volume when your camera is still. If you notice that your camera tracking data is jumping around a lot when your camera isn't moving, you can adjust this tracking de-jitter to try and remove some of it and smooth it out. Now that I've explained the main functions of your input settings, I'll navigate over to Monitor 4 and select Studio. You can see in Preview 1 and 2 that there's now a checker pattern. Each one of these squares represents half a meter, so this 9 plus this checkerboard pattern equals 1 full meter. On the right hand side with the studio view enabled, you should see all of the studio settings. The studio settings also correspond to this green studio square. You can access these studio settings at any time using this green square, even if this studio tab isn't enabled in Monitor 4. Before we calibrate the studio, we need to set the origin. Select this orange square labeled Origin 4. With this selected, you should see all of the settings on the right hand side. The main setting we are going to use here is the Detect Origin function. In order to use the Detect Origin function, we will need an Aruco marker. This is the Aruco marker that Aximmetry recommends using. You can find this in the Aximmetry documentation. Once you download and print this, you will need to place it on the studio floor. I've placed this marker in the middle of my tracking volume, so I will tilt my camera down to show you where it's placed. I calibrated my tracking during the calibration process, so my origin is already at the center of my tracking volume. You can see where the 0,0 point of my origin is located by this virtual marker. When we trigger the Detect Origin function, it will place our origin at the center of the Aruco marker. I will select this trigger function in the settings on the right. You should see that my studio snaps into place based on the placement of this Aruco marker. I will turn off the studio view and select Input so you can see a better view of the Aruco marker. I will navigate back to the studio view. Now that our origin is set, I will be able to start the calibration of our studio. In the Monitor 4 tab, just make sure that Studio is selected. The studio settings correspond to this green studio square, so make sure that's selected. And on the right hand side, you should see all of the settings for the studio. Front wall, left wall, right wall, back wall, ceiling, and floor all correspond to the physical studio walls, and then anything labeled green all corresponds to the green surfaces of your studio. So green front left, green front right, green left, green right, green top, green floor will all be used to tell Aximmetry where the green surfaces are in your studio space. As I go through this process, it will all start to make more sense. We will start with the front wall, which is the wall that's in front of my camera. This will also be the main location of our main green screen wall. I will start by tilting my camera back up so you can see this wall. All of the values that we will input will be in meters. With the origin placed, you can take a measurement from the center of the origin to the front wall. My front wall is about 2.5 meters from the origin, so I will start by inputting that value for front wall. Once we have the front wall placed, we will start to input all of the rest of the values. My next studio wall is the left wall, so I will pan my camera to the left wall. Once the left wall is in the view of my camera, I will find the corner where my left wall and front wall meet. I will then go to the left wall setting. I will click and drag to adjust the left wall setting until the virtual wall matches my physical wall. I'm just trying to position the corner of my virtual space with the corner of my physical space. You can also achieve this using physical measurements. So you can measure the distance from the center of your Aruco marker to the left wall and then input this in left wall setting. For this tutorial, I'm just going to eyeball it. Next, I'll pan my camera to the right wall and do the exact same thing. I will go to the right wall setting, click and drag until my right wall starts to line up. Again, I'm just trying to match the corner of my physical space to the corner of my virtual space. This whole process is really just about matching perspective. You can see that the green screen is kind of hanging over here. After we get the studio walls calibrated, we will address the green screen walls. For the back wall setting, this is the wall that's directly behind my camera. In this tutorial, I'm not going to worry about the back wall because it's not really relevant. I'm just going to leave the back wall set to 4, but you can adjust this for your own calibration. The next value that we will adjust is the ceiling, so I'll tilt my camera up to find a corner of the ceiling. Now that I have a better view of my right wall corner, I'm going to make one quick adjustment to the right wall setting. I'll just go ahead and bring my right wall back out until it matches with the corner. During this process, it's usually easiest to find the walls when you're looking at a corner. Now I'm going to adjust my ceiling. I'll go to the ceiling setting and click and drag to bring the ceiling down. You can see that my front wall, right wall, and ceiling are now in the proper position by looking at this corner. Next, we will adjust our floor. I will just tilt my camera down so that you can see the floor. Since we used an Aruco marker to detect the origin, this value should be set to 0. I will adjust this setting just so that you can see how you can offset the height of the floor. With the floor setting selected, I will hit Ctrl Q on my keyboard to reset the value to 0. Once you're happy with the placement and calibration of all your studio walls, you can move on to the green sections. For the green front left setting, this is the left side of our front wall, so I will tilt back up and pan to the left so we can see the left side of our front wall. Now with the green front left in the view of the camera, I will adjust the green front left setting until this green is only on the green screen. I will slowly increase this value until the green screen starts to come in. We only want the green overlay on the green areas of our studio. Next, I will bring in the green front right. So I will pan my camera to the right so I can see the green front right. Now we will adjust the green front right setting. Click and drag slowly up. Again, we only want this virtual green overlay on the green areas of our studio. The green left and green right settings are if you have a second green wall in your studio. Since we're looking at the right wall, I'll go ahead and increase the green right just so you can see what it does. Since I don't have a secondary green wall in my studio, I'll reset this to 0. Now I will adjust the green top setting. I will tilt my camera up so that you can see the top of my green screen. Now I will slowly adjust this value up to bring the green screen down. You can see in my live camera feed that I have a little bit more green screen height, but I have a light hanging in front of my green screen, So I'll want to make sure that this green top value doesn't include that light, because anything that is in this green space will be visible in the final composite. Finally, we will move on to the green floor, so I will tilt my camera down so you can see the floor. In the preview, you can see where my floor tracking volume meets my green screen, so I will just adjust this green floor value until it is only on the green area. Once we've completed the studio calibration, there's only a few more settings in this studio tab. We have wall opacity. Show green will turn on and off the green area of our studio. Show non-green will turn on and off the non-green areas of our studio. There's a show window model. There's a use talent tracking area, as well as show talent tracking area, talent track area size. Once we have show talent area enabled, you can see the talent tracking area in yellow. You can adjust the talent tracking area using the talent track transform. You have a show marker 1 setting. This virtual marker is placed at the origin of our tracking volume. You can adjust the position of this marker using marker 1 position. You can have more than one marker in your virtual scene using show marker 2 and then adjusting the position. You can use these markers if you're having trouble during the calibration process. If we navigate back to the Input 4 tab by selecting this Input 4 box, we will now use the Detect Tracking Delay function that I mentioned earlier. I will pan and tilt the camera around so that you can see the delay between the live camera feed and the camera tracking data. You'll notice in Preview 1 and 2 that it looks like the studio is not sticking to the physical space. This is because the tracking data is coming in faster than the video feed. Around the edges of my Aruco marker, I've placed some red tape. I will tilt my camera down until this Aruco marker is back in the view of my camera. I will navigate back to this Detect Tracking Delay function and turn it on. Once this is enabled, Aximmetry will ask you to place a distinct red marker or choose a different color. Finally, once Aximmetry recognizes the red marker, it will ask you to rotate the camera left and right, panning. You'll want to make sure that you're only panning and not tilting the camera. Once this is complete, the tracking delay setting here will be updated automatically. I will make sure that there's plenty of light on this red marker. I will also reposition my camera so that there is a very clear view of this red marker. Aximmetry will then auto-calculate the tracking delay for me. You should see a message that says delay found and set. I will now pan and tilt around my studio with this delay set. You should see that the studio is now sticking. With the delay set, you shouldn't see any sliding or drifting in your studio. With my tracking delay updated to 2.1 frames, I will adjust my zoom delay. Since I don't have a zoom lens, when I enable Detect Zoom Delay, Aximmetry will ask me again to place a distinct red marker. Once it finds the distinct red marker, like the one on my chair, it will ask me to zoom in and out on the camera, but I don't have a zoom lens. The zoom encoder function in my project is handling my focus. By racking my focus from minimum to infinity, I've found that it's about 2 frames, so I'll just manually set that here. Now we need to key our green screen. Navigate to the Monitor 4 view and select Keyed. In Preview 1 and 2, this will show us the keyed view. On the right-hand side, we should see the keyed settings. Select the drop-down next to Monitor Mode and then select Input. Next to Background Color, select this green box. In the bottom left, there's an eyedropper tool. Click and hold this, and then select the green color of our green screen. When we let go, it should update the background color. Select OK. Change the monitor mode to matte. This will show us a black and white image. We will now use these low cut and high cut values to adjust the black to be completely black and the white to be completely white. The low cut value will adjust the black, and the high cut value will adjust the white. Navigate back to Monitor 4 and select the final view. This key is looking pretty good. I will select Keyed in Monitor 4 just to make some final adjustments. I can change my monitor mode to Final and bring this low cut value up a little bit more. I'm just trying to get the cleanest key possible. That's probably good enough for this tutorial. By this point in the tutorial, you should have all of your inputs set up. In the keyed view, I'll go to Final, make sure it's on Final. I'll go to the Studio view. Studio's calibrated. Now we can select the Final view in Monitor 4. Once you select Final, it should open the settings in this orange Scene tab. If it doesn't open the settings automatically, go ahead and click on the orange Scene tab. Around the bottom edge of my frame, I have a tiny little gap. To fix this, I will go to the Edge Expand setting in my Scene tab. Your camera calibration might not have this problem. I've found that 0.03 fixes it for mine, so I will just Edge Expand 0.03 and it fixes that little gap. Just below the Edge Expand setting, you'll see a Use Billboard setting. I will turn this on in a second. Before I turn on this use billboard setting, I like to place myself in the scene. Make sure that you've selected this orange scene setting. And then on the right hand side, navigate to base cam transform. By adjusting these position values, I'll be able to reposition myself in the scene. I will start by moving myself away from this wall and then changing the rotation value of the Z to 90 degrees. For this, I'm just trying to place myself in an area that's similar to what we did for the virtual camera. Your values will probably be different. Once we're happy with the placement of our scene, we can go ahead and turn on the use billboard function. You can see that my chair has now disappeared. Navigate to billboard 4A and turn on this little light bulb. Select the billboard 4A node to bring up the billboard settings. On the right hand side, you should see the settings for this billboard. At the top of the billboard settings, you should see a lock to camera function. This will auto place the billboard at this distance. You can adjust the distance and scale of the billboard using these settings. If you watch preview 1 when I turn this on, it'll place the billboard in front of my camera. I'm just going to turn on the lock to camera function. Since this light bulb is enabled on billboard 4A, you should see a checkerboard pattern. You should see that the transformation properties are updating in real time. This is because of our camera tracking. Once the billboard is placed, we're going to want to turn off the lock to camera function. You don't want to leave this lock to camera function enabled because it will always be placing the billboard in front of the camera. Navigate to the lock to camera function and turn it off. You'll see that once the lock to camera function is turned off, the transformation stops updating in real time. Now for the final placement of my billboard, I'll tilt down to the floor. From this view, I'll make some final adjustments to the placement of my billboard using the transformation settings. I will usually place this just in front of the feet of the talent. If I move the billboard too far, you will see that it starts to clip the talent. Using the billboard function allows us to place our talent behind virtual objects in our scene. Now I'll navigate back to billboard 4A and turn off this light bulb. This removes the checkerboard pattern that is placed on our billboard. Now if I navigate back to my scene settings and I start to make adjustments to the base cam transform, I will go back to the billboard 4A, turn on this light bulb again so you can see this. You can see that it looks like my chair is now being clipped through the floor. This is because if we adjust the base cam transform of our scene, we also need to adjust the position of our billboard. If we don't make adjustments to both, then our talent will end up being clipped. Just keep in mind that when you're using a billboard, the distance between your physical camera and your talent need to match in the virtual and physical world. If we don't make the adjustments to both, you will end up with something that doesn't look practical. Hopefully this makes sense and I've explained it in a way that's easy to understand. Everything needs to be very specific to the physical world in order for the tracked camera to work. Again, I will turn off the light bulb on billboard 4A. You can see that the distance between my billboard and my camera is correct. Everything in the physical and virtual world is 1:1. With these adjustments out of the way, I will explain the final settings. If you need to make color correction adjustments, that's in this blue box labeled Adjuster 4. With the blue Adjuster 4 box selected, you will see the settings on the right. As an example, I'll bring the brightness to 0.5. You can see that this has affected the brightness of my billboard. If I select billboard 4A, there's a few more settings that I want to go over. The main setting I want to talk about is this lit function. This lit setting will only affect our incoming video feed if the billboard is turned on. If we go back to the scene node and turn off billboard, you'll notice that the lit function no longer affects our footage. I will turn the use billboard function back on, and you will see that my billboard is now lit with the lighting from the Unreal scene. I will now go back to billboard 4A and toggle through a few of the settings just so you can see what they do in real time. Render to depth allows our billboard to be affected by the focus that we set on our physical camera. Inverse tone map will affect the color correction of our billboard. Alpha correction is another adjustment for color correction. Now that we're fully set up and calibrated, I will pan and tilt around my space so that you can see what it looks like when everything is set properly. I will start by adjusting the focus on my physical camera so you can see that it is affecting the billboard and the virtual world. Now as I pan and tilt around the studio, you can see that the chair is sticking to the floor. There's no significant drifting. Now that this tutorial is complete, you should have a pretty good understanding of how to set up a virtual and tracked camera using the mixed camera compound. I will make sure to save everything using the save button at the top. Once you've calibrated your studio, you should be able to bring any custom Unreal project into this compound. One of the great things about this process is that now you have a fully calibrated studio, so you can use this as a starting point in any of your future productions. Hopefully this video was helpful in getting you started in Aximmetry DE Composer with a mixed camera compound. Be sure to like and subscribe for more videos, and thanks for watching.